Okay. All right, I'll get the door.
All right, folks, welcome to the Science Seminar. We're happy and pleased that you came out today, and we have a special treat in store because our own Julianna Glinskas, chemistry physics major here at Paterno, is going to be giving the Science Seminar presentation. Just a couple of words first, though. Julianna is a weather buff, if you will. She loves weather, and so she got an appointment with the National Weather Service last summer, and in Shreveport, just very close to us. And we have 3 representatives with us today in the National Weather Service. And so give these folks a hand for coming out. And anyway, also, Julianna did some research work with them last summer, and she did this for her undergraduate research credit this last fall here at Paterno. And so I'm pleased to introduce Julianna to you today, and so I hope you enjoy her presentation. Let's give her a warm round, too.
All right, good morning. I'm Julianna. The research, I've been with the Weather Service as a student volunteer for the past 2 summers. I worked this past summer with Mariama Feaster, who's a meteorology major at Jackson State, and Jason Hansford and Davion Hill, who are both meteorologists at the Weather Service. So to kind of give an introduction on what's happening, here I have a picture of the entire Red River Basin. And it starts over in New Mexico, comes down to Shreveport, and flooding in the lower to middle portion of the Red River Basin is actually pretty rare. And what that means is this area right here that we're going to focus on. And there are a few locations that I want you to be aware of. One is this is Shreveport over here, and 2, this is Lake Texoma. Lake Texoma is going to play an important role later. And then I also highlighted Longview for you guys to see. We're at kind of the base of, we're at the southernmost edge of the river, not really in the basin. So from May of 2015 to May of 2016, over the past year, we had 5 separate flood crests along the Red River in Shreveport. This breaks the previous record of 3. And our biggest one was the biggest since 1945 and the first since 1990. And these crests occurred during one of the strongest El Niños on record. So this kind of led to the question, what impact did El Nino have on the flooding in Shreveport? And so that was the overall goal of this research. So to kind of give an overview of how I broke this down, we really looked at synoptic air patterns to see if there was any correlation, any similarity. So we first looked at the composite mean, which is the average of the upper air patterns for a certain month from 1950 to 2015. The next thing we looked at was the flood El Nino mean, which are basically the years where there was an El Nino and at least flooding or near flooding crests occurring along the Red River. And then we compared that to what was observed during a specific month during 2015 or 2016. After that, we also considered outside impacts such as tropical storms or other man-made effects. So to give a quick overview of what El Nino is the warming of sea surface temperatures along the equator, and it's associated with changes in the weather patterns worldwide. And some of those patterns, these are generally the summer impacts that you see, and so generally not as big of an impact on the U.S. during the summer. However, in the winter, you see a cool and wet pattern that forms over the U.S. And to kind of zoom in, this is because we have the polar jet stream that kind of goes up over the top and warms up Alaska a little bit, with the warm air allowing to go up further north. And then an extended Pacific jet stream, which allows for more storms to come down that way. So in terms of strength, these are kind of the sea surface temperature departures that separate a weak El Nino from a moderate to a strong El Nino. We were at 2.3 at our highest, and so this was an extremely strong El Nino event, and so that's why it really caught our attention. So to do this, I broke it down by each crest to see if each crest could be affected by El Nino. So looking at the first one, this is a geopotential height graph, and what this is It's a graph of at what height is a certain pressure reached. So this is the 700 millibar level. So colder air is dense, so it'll reach 700 millibars at a lower height and a higher height at warm temperatures. And what we use these graphics for is to see where our troughs and ridges are. And so to point some of these out, this was May of 2015 where we had the flooding rains for this crest. We had a long wave trough over Baja California. This was very deep and very unusual for what we would normally see. And we had a short wave trough right here, which kind of provided the lifting mechanism for heavy precipitation. The result is we had over 15 inches of rain in a widespread area, particularly along I-35 around there. And so this was a huge flooding event along the Texas-Oklahoma border. And as a result, we had an unprecedented event where Lake Texoma spilled over for only the 4th time in its history. And this is a video of the water going over the spillways. Now keep in mind, this is only the 4th time in its history that this has ever happened. So this is a really huge event. And all of the water that is coming down this spillway is uncontrolled, because Lake Texoma usually does a really good job at holding back that water from impacting Shreveport. So anything that was spilled over was uncontrolled, and it was flood water that was going to reach us. And as a result, we reached a crest. Our first crest was at 37.1 feet, and this was the highest crest since 1945. And this was a huge, huge event. So in looking at the upper air patterns and comparing the graph we saw earlier to the flood El Nino mean and the composite mean, what you see is a lot of differences in that, the trough right here is a lot deeper. And in terms of El Nino, at the time of this crest, El Nino was actually pretty weak. And so there might have been a stronger push for El Nino being a cause if El Nino would have been strong at the time. But because it was weak, it kind of put a little bit of doubt as to what impact El Nino alone might have had. And so that was the prevailing thought for crest number 1. Now crest number 2, June is kind of an interesting month because this is where we start to dry out a little bit. We have a ridge of high pressure that kind of sets in, and so we allow it to dry out, and that's exactly what happened. There was actually not a lot of rain from storm systems coming through the upper air. However, we did have an anomaly come through in the form of Tropical Storm Bill. And the path that Tropical Storm Bill took led it right over the exact area that had flooded just the month before. And so what you get as a result is this is the crossing of the Red River at the Texas-Oklahoma border. And I highlighted this because this says this is the underpass at 14 feet 6 inches. And then at the crest, it was completely covered again. So you're having major flooding happening all over again in the exact same areas. And as a result, Lake Texoma actually overspilled again. So not only was it rare for it to overspill at all, but it overspills for the 2nd time in under the span of a month. And so as you can see, Lake Texoma barely has time to recover before Tropical Storm Bill hits, and then it overspills again. So then once again, even though Shreveport and the Shreveport area did not receive as much rain with Tropical Storm Bill, because this area received a ton of rain and it was already oversaturated and Texoma overspilled, we got another flood crest, and this time it was in the minor flood stage. Now, because of the upper air patterns that we saw in June with the ridge of high pressure and the fact that, pretty much Tropical Storm Bill was the main source of rain for the month, it was pretty much determined that without Tropical Storm Bill, crest number 2 would have never happened. And so for that crest, El Nino did not have an impact. Now moving on to crest number 3, this was in January 2nd of 2016. So we started off from July to mid-October of actually having a flash drought. So you've heard of flash floods. This was a flash drought. And so we had a very unusually strong high pressure that just settled over the area and stayed for a long time. However, this went away towards the end of October and stayed through November and December. And from October through November, there were a lot of rain events that occurred, little rain events that were dropping 2, 3 inches at a time. And what that did is that resaturated the ground. So once again, you know, it was able to dry out. Texoma's good again, but it's resaturating and setting up for the next flood. And the final event that occurred was on December 28th, where you're having over 6 to 8 inches right in here. Now, notice Lake Texoma is over here. So Lake Texoma doesn't have the ability to hold back any of these floodwaters. So all of this that is happening in the lower Red River Basin is going to go straight to Shreveport without much flood control systems to really hold it back. And so it was great in getting rid of the drought completely. It was a good drought buster, but as a result, we have Lake Texoma again, and we've got over 15 inches of rain, which was 150 to 300% of normal. This is the average from November to December of 2015, and so you have a lot of above normal rain that's concentrated east of Lake Texoma. And so as a result, all of that water quickly overwhelmed the river, and we crested in the moderate flood stage at 31.6 feet. So looking at this, one of the things that I found is flooding is actually pretty uncommon for the fall and winter months. Even during an El Nino year, we really saw not a lot of difference between the flood El Nino mean and the composite mean. And so when you bring in what we observed for December of 2015, we really saw something that was very different. Now, in looking at the different years that we had the flood El Nino, that we had floods during El Nino years, there's only one other year where flooding occurred in the fall to winter months, and that was 2009. And so the crest happened in November, the heavy rains happened in October. So I compared October and December because those were the heavy rain events. And what we saw was an interesting similarity in that you both have a similar trough set up in a similar way. And so what it was determined is that El Nino can have an effect during the winter months. Moving on to March 15th, this was a very unusual event. We had a cutoff low, as you can see at both the 700 and 500 millibar levels, where we just had a lot of moisture that was being funneled directly into this area in the Red River Basin. And we got a record-setting of 12.8 inches of rain in Shreveport. And this was also a huge flooding event for Monroe, where actually the I-20 had to be closed for a short time because of the flooding. But we also got a lot of rain in the Red River Basin. And these are the rainfall totals. This is the one day for March 9 and the one day for March 10. And so what you're getting is these pinks are 6 inches and above. And so you're getting a lot of rain in a very concentrated area. This was the most localized flooding event out of all the crests. And so this was pretty much, it rose the river pretty quickly in Shreveport because it happened so localized. So the rain fell east of DeKalb, and it fell in the area. So as you can see, this is the monthly precipitation for March of 2016. That 2-day event accounted for most of the precipitation for the month. And so as a result, you can really say that the cutoff low was really the main flood event, and that's where we crested again in the moderate flood stage. And so as a result, you look at the monthly mean for March, and you really don't see a pattern that really even matches the flood El Nino mean. And so it was determined that the cutoff low alone is what really ended up causing the flooding. So on to crest number 5. From March to April, there were a bunch of, once again, continuous rain events that prevented the basin from drying out. So you have a similar event setting up. Once again, we have a final trigger event where you have a bunch of precipitation in a concentrated area, this time up here. This all feeds down into the river right here around Texarkana. And so this was about 8 to 10 inches of rain, and most of the basin received over 3 inches of rain. So as a result, once again, you're getting a lot of rain over 10 inches and this is all east of Lake Texoma again. So comparing El Nino, one of the interesting things I saw about this is you see almost no difference between the composite mean and the flood El Nino mean. So that was an interesting thing because we're starting to get into the months where flooding normally does occur. So it's interesting that you don't really see a huge difference between those two. However, I compared April of 2016 with the previous year of April 2015. 2016 was a little bit stronger in El Nino intensity than 2015. And so you see a little bit of a similarity, particularly at the 700 millibar level, but you don't at the 500 millibar level. And so it's kind of a stretch, but you can kind of say that maybe because El Nino was a little bit stronger in April of 2016 than 2015, it's possible that that might have caused more rain, might have helped more rain come to the area. It's a little hard to say that definitively, but it's possible that El Nino definitely could have had an effect on it. And so at the end of the day, the primary reason was you just have a bunch of rain events. The basin's not allowed to dry out. And so as a result, even a smaller amount of rain can easily overwhelm the river. So when I was looking through the flood El Nino means in the past El Nino years where it flooded along the Red River, I noticed that two of the strongest El Ninos were not included, and that was the 82, 83, 97, 98 El Ninos. And that was really weird for me because I figured, if El Nino has a really strong correlation, shouldn't there be significant flooding every time there's a really strong El Nino? And so I decided to dig through and look at precipitation and upper air maps from these times to see, why was this, what correlations could I find? And I found a few interesting reasons. The first one is there wasn't a lot of rainfall during these years. It was really interesting. This was particularly true during the 97-98 El Nino. There were a lot of times where the Red River Basin even received below normal precipitation, and so you don't get the flooding rains and the consistent flooding rains that you saw in 2015, 2016. The second thing was the heaviest rainfall usually fell north of the Red River Basin. This was really interesting because sometimes parts of northern Oklahoma would get huge flooding events. However, because it was north of what drains into our river, it wasn't affecting us at all. And the other thing is rain that did fall was all able to be carried by Lake Texoma. There were a couple times where there was above normal precipitation up in the panhandle of Texas, but because it wasn't enough to overwhelm Lake Texoma is able to hold that water and release it in a more controlled manner, so you don't get that flooding rainfall and flooding flow that you would get if it weren't there. Another thing is the flooding that happened in the Shreveport area was mainly localized flooding instead of extensive river flooding, and what that means is you're just getting like street flooding, stuff like that. You're not getting the extensive river flooding that we saw with 2015, 2016. So the next portion was to confirm or deny this with outside factors. Was there anything that could have affected the flooding capabilities of the Red River in Shreveport? So the first one is obviously Lake Texoma. Lake Texoma was built as a flood control system, and it has done its job. Even though it spilled over in 2015, had it not been there, our crest could have easily been a lot higher and a lot more devastating to the area. And over the course of history, Texoma has done a nice job at really controlling the amount of flood crest we have. Another thing is the levee system, including the locks and dams. Those have been really good. The levee system held for the most part in Shreveport. There were a couple leaks, but overall it held, and that was a huge factor in keeping flooding waters from, hurting more of Shreveport. Another thing, and this ended up being a big thing, was development along the Red River. So since the 1990 flood, there's been an explosive amount of urban and commercial development along the Red River. And it was built on land that was inside the levees, which was previously wetland and channel width. And so what happens is you narrow the channel. And as a result, what happened is we had lower flow rate, lower CFS during the 2015, well, 2015 was when we really noticed it. Then the 1990 flood, but we had a higher crest. And so when you narrow the channel width, you really negatively impact that aspect of the channel being able to hold more water. And then the ultimate outside factor that we saw with crest number 2 was tropical systems that can form. And whether or not tropical storms can be influenced by El Nino, that's the topic for other research. But we found that, with crest number 2, had Bill not occurred, we wouldn't have gotten a crest number 2. So that's pretty much what we found. So overall, we found that El Nino can be a strong contributing factor in the fall and winter months. It does have the capability of increasing an already existing flood potential, which we kind of saw with crest number 5, where, it was a little bit stronger. It might have helped increase the flood potential that was already there. However, El Nino alone does not predict the likelihood or severity of river flooding in Shreveport. And so it has to be kind of taken with a grain of salt that, just because we have a strong El Nino, there might be flooding, but will it be as severe as what we saw? That's kind of up for debate. So then, on that note, what were the primary causes for the flooding? So we had back-to-back rainfall events. That was a huge deal that we never really had a chance to dry out. We really never had a chance to recover before we got hit with the next rain event. And so, and the next main factor was the outside factors, such as the development that occurred along the Red River that has the potential to also cause higher crests in the future. And so that's one thing to watch when building along the Red River is, what will this do to affect channel width? And so, with that, I'm done. Yay.
Okay. Question for Ms. Glinskas? Anybody?
You're from Modesto, California, right?
Yes.
Which, is your house underwater right now?
No, my house is not underwater. We live a few miles north of the river, so if it floods my house, then the entire city of Modesto is underwater too, so. So, yeah. Cool stuff.
So what's the cause of El Nino?
It's the stopping of the trade winds along the equator. And so normally you have trade winds that kind of disperse the heat of the ocean around. But when those trade winds stop, you get a warming of that ocean. And so
What stops the trade?
that is still up for debate, if I remember correctly. I don't... I'm not sure.
It's a recognized phenomenon that occurs on a regular basis. Ancient sailors were aware of this phenomenon and how it impacted fishing there. So the answer to your question is the sun, but why on this frequent of a basis, that type of thing?
The sun's always
Yeah,
right.
yeah.
Yeah.
Is El Nino like yearly, seasonal, or is it just occasional?
It's occasional. I think an El Nino event happens roughly every 5 to 7 years is what I saw in my research. And so it goes back and forth because you have El Nino and then you have the opposite of that, which is La Nina, which we were kind of in a really weak La Nina event. And so it oscillates between the two.
The other thing to remember too is, if you remember, she showed you up there, a half degree, a 0 to half degree is a weak. Half degree to 1 degree is a moderate, and then 1.5 above is considered strong. 1.5 degrees. That's the difference in temperature from that wall to that wall. So these are very subtle things, but they have big impacts.
Yeah.
So does La Nina cause problems like El Nino?
That's kind of the topic and the direction for future research that I haven't really had a chance to look into, because actually in looking at the flood years, like 1990, the last major flood, that actually occurred during a neutral year. And so I haven't had a chance to really look into neutral and La Nina years and if those patterns look like El Nino. Do they look like La Nina? I don't know. That's kind of the next direction I would take it. But yep. Yes.
I'm a big Star Trek fan. And Star Trek The Next Generation, they have weather control on Earth, where they can control the weather in San Francisco. And when that got knocked out in one of the episodes, then they're having giant winds and rainstorms they couldn't control. So what would it take to actually control El Nino?
Well, you just got to start dumping cold water, pail by pail. Just.
I think it has to be some giant, huge amount of energy that's coming from somewhere
Yeah.
to do it, but they, of course they never explained that.
The thing with El Nino is it covers such a wide area, and the 2015 to 2016 El Nino was kind of unusual because there was also the blob, which was a warming of the ocean that was kind of north from where you would normally look for El Nino. And so there were a lot of unusual things that happened with this particular El Nino that we're still trying to figure out why and what impact that might have had, because it wasn't always the standard El Nino warming that you see where it was concentrated in that area. You had El Nino warming that was further west than normal. We had it further north than normal, and so it was a pretty widespread event. And so it'd be interesting to see, is 2015, 2016 just a huge anomaly, or is this what El Nino is going to become in the future? I don't know. So
Yeah, that's a good question. How does global warming affect El Nino and La Nina? Will one become more frequent than the other, or can it be predicted? Or thoughts on that? Like any of a panel of experts?
Well, I mean, if you warm the earth, okay, you're going to put more moisture up into the atmosphere. And our weather is basically a giant heat engine, so it's always trying to balance itself out. So if you put more moisture in, it's going to come out somewhere. Okay, and also, if you start melting polar ice caps, that water is going to go somewhere. You change the salinity of the oceans, that's going to impact the currents in the oceans. How many of you have seen The Day After Tomorrow? Everybody, raise their hand, please. Okay. The only reason people like to live in England and the Scandinavian countries is because of the Gulf Current. If the Gulf Current's not there, that's going to turn into a really cold place, more like Siberia than what it is now. So, you'll still have those patterns of El Nino, or above normal temperatures and below normal temperatures. Those impacts will probably become greater as we get more extreme.
Right. Any other questions? Oh, there's some over there.
What would you say to the not as significant movements or flooding events that occurred further west on the Red River and northwest on the Canadian River just a couple of years before that, when we weren't really into the El Nino stage yet? Would you say that's a different correlation, or?
So you're talking north of the Red River Basin?
Yeah, so regionally pretty close, but between the Red River Basin and the Canadian River.
Yeah, you have some similarities, just because you're in roughly the same area, and so there are some things that are going to be the same. But like, for instance, where I was talking about how some of the flooding rains that fell north of the Red River Basin, so during those El Ninos, you're going to get a different impact. And so, it's interesting how even with a little bit of latitude change, you can still get kind of different weather patterns like that. And so it would be kind of interesting to see, what they observe during each of these El Nino events. Did they observe flooding crest the same years that we did? That's something to look into, definitely. But I would say that there will be a similarity overall just because you're talking about roughly the same quadrant of the U.S., but I would say you can even find differences just up to the basin above us.
Okay.
I got a couple announcements before we're done here today. As you've seen, Julianna had a special opportunity to work with the National Weather Service during the summer. And I would encourage those of you who are interested in doing some sort of summer research or some sort of special kind of experience during the summer to look for those opportunities early in the spring and start applying for summer opportunities, or talk with these folks about if you're interested in those kinds of opportunities. So that's what I'm going to encourage you to do, because that's what Julianna did. She looked for the opportunity and she got one, and you can see that it's a very, very valuable experience. And so I encourage you to look into those. Okay? The other announcement is we've got science seminar again.
Next week.
Next week.
We'll talk about research done here at Laterno.
That's right.
Next week.
And I think I know the speaker, right?
Yeah, you might be acquainted with
Yeah.
that.
So, anyway, come on out next week and we'll have another science seminar for you. Thanks for coming. Let's give our speaker another hand.
Join us for lunch to talk more about the weather with other people. We have a question.
Right now it's gonna go over. You did so good! Thank you.